Good morning. Myself Dr. Indu Nayappi, Associate Professor, Artificial Intelligence and Data Science. So today we are going to discuss about the case study of full-wave rectifier. So previously we have seen about the half-wave rectifier. There the efficiency of half-wave rectifier is nearly only 40%. That means nearly 60% of the power is being wasted as heat. So that is why we are compelled to go in for a full wave rectifier. So the performance of a full wave rectifier is based on the efficiency and the ripple factor. So there are two types. We have a center tap and we have a bridge rectifier. So center tap uses just two diodes, bridge rectifier uses four diodes. But we have output for both the positive and negative cycle of the input wave. So now I call upon my students of the first year AITS to discuss about the case study on full wave rectifier.
Good morning, I'm Joshua. I'm here to talk about the introduction and real life need. A full wave rectifier is a circuit used to convert AC, alternating current into DC, direct current. In our daily life, most electronic devices like mobile phones, laptops, TV, DC power to operate, but electricity supplied to our homes is AC. So we need a system to convert AC to DC, and that is where rectifiers are used. A full wave rectifier is more advanced than half wave rectifier because it uses both half wave and AC signals, which improves efficiency and output quality. This case study focuses on how this circuit works, why it is important, and where it is used in real world application.
Hi, I'm Ambiram. I'm going to explain about types and working principle of a full wave rectifier. There are mainly two types of a full wave rectifier: center tapped rectifier and bridge rectifier. In center tapped rectifier, a transformer which a center tapped and two diodes is used. During the positive half cycle, one diode conduct current. During the negative half cycle, other diode conduct current. The two diodes conduct current at the same time, ensuring the current always flows in the same direction across the load. Because both the half of the AC wave are used to output in a continuous oscillating DC signal, which is more efficient and smoother than half-wave rectifier.
Hi, this is Abdulrahman. I am going to explain about the waveform and output of the full wave rectifier. The output of the full wave rectifier is not pure DC but a pulsating DC signal. This means the voltage rises and falls but never goes negative. The waveform consists of positive pulse for both half cycle of the input AC signal. To make the output smoother, a filter circuit, usually a capacitor, is added. The capacitor stores charges during peak voltage and releases it when the voltage drops. Reduce ripple. Ripple factor is much lower in a full wave rectifier compared to a half wave rectifier, which makes it more suitable for sensitive electronic device that requires stable voltage.
Hi, I am Karthik. Now I am going to talk about performance, efficiency and comparison. The efficiency of full wave rectifier is about 81.2%, which is much higher than 40.6% efficiency half wave rectifier. It also has better transformer utilization and produces higher average output voltage. The ripple frequency is twice the input frequency, which makes filtering easier. However, it has some disadvantages such as increased cost and complexity due to more components. In the center taped version, a special transformer is required, which increases size and cost. Despite these drawbacks, full wave rectifiers are preferred in most practical applications because of their better performance.
Hello, this is Joshua. I'm here to talk about application case example and conclusion. Full wave rectifiers are widely used in power supply circuits, battery chargers, radios, and electronic devices. For example, in a mobile charger, a bridge rectifier converts AC from the weight socket into DC, which is then regulated to charge the battery safely. Without this circuit, electronic device cannot function properly. In conclusion, the full wave rectifiers play a critical role in modern electronic by providing efficient AC to DC converts in its advantages such as high efficiency, low ripple, and better output. Make it an essential component in almost every electronic system we use today.
Common case study challenges. Diode voltage drop. Real diode introduces a small voltage drop of 0.7 for silicon that must be considered in simulation. A ripple factor without filter capacitor, the DC output will still contain more ripple. Ripple factor is much less in a full wave rectifier than a half wave rectifier, where in full wave rectifier it is 0.486 and half wave rectifier it is 1.2. Transformer requirements. Center tap transformer are larger and more expensive than those used in the bridge rectifier. Even the filters, capacitor filter is very small and less expensive, whereas the inductor filter is more expensive and bulkier structure. Thank you.